In recent videos, you have seen WasmX plugins for Python and Golang smart contracts. Today we are taking one step further and bringing you JavaScript smart contracts. Specifically, in this demo, these are JavaScript contracts that are interpreted by our JavaScript interpreter meta contract. We talked about meta contracts before. They are core smart contracts in WebAssembly that extend the blockchain and are governed and upgraded by consensus. The JS-WasmX plugin that you will see demoed today interprets JavaScript and is compatible with ECMAScript 2020. It can also have access to WASI API, and it is treated as any other smart contract on WasmX. So JavaScript becomes a first-class smart contract language, and this is an example of a very simple storage contract in JavaScript. This is the usual boilerplate code for the main function, which is the execution entry point, and the instantiate function, which is the entry point for the contract instantiation. You can think of this as the smart contract constructor. And this is the actual contract logic in these two functions, store and load, which store a string variable to the contract store on the blockchain and then load that variable. And the WasmX module is our JavaScript SDK, which gives access to blockchain features. And now the demo. This is a dApp where we can upload our JavaScript source code, instantiate it as a contract, and then interact with it. And this dApp is connected to a Kepler wallet, which is connected to a local chain that I am running with WasmX. And I will use the same JavaScript code that you saw earlier with an instantiate function, a main function that either calls store or load based on the input data. So we will click on instantiate, and we have a first transaction that uploads the code with a WasmX message store code. And then we will have a second one that instantiates this code into a contract with a WasmX message instantiate. You can instantiate multiple contracts from the same code, but with potentially different instantiation arguments. So right now, these two transactions have gone through, and we already have the contract address in both hex format and beg32 format. And we have the receipts here for the upload transaction, and we can see our code ID 22, and then the receipt from our instantiation transaction, and we have the contract address here, which has been filled in this form. And we can also see the transaction hash on our local explorer. And now we can interact with this contract. Let's set our input data. So we will call the store function with one argument. I say hello, and then we execute this transaction. We execute a WasmX message execute contract. And what this does is stores this string in the contract storage, and we get our transaction hash, and we see the transaction here. And now we can call the load function as a query with no arguments. And we see that this is the data that is stored on the blockchain, and we can decode this, and it is I say hello. you can have, even on the same chain, smart contracts written in Solidity, Vyper, Yule, Rust, AssemblyScript, Python, Go, JavaScript that cover the EVM specification, the CosmWasm specification, and our own WasmX specification, and have all of these contracts collaborate with one another. And all contracts can be used with either Ethereum wallets like MetaMask or Cosmos wallets like Kepler. And you will see this in future demos.